Good morning. This is going to be a review of one-point perspective and an introduction to two-point perspective. I just wanted to show a few things to begin. When you do a perspective drawing, it's called a plate, and you can use this architectural lettering, which is like all bold capital font. And when you have a plate, you can make a 1-inch line with your ruler, a 1/8 inch line with your ruler, and section off areas so that then you can write your name, what class, what exercise, and such like that. That's a really nice way to mark your plates. So I will show you that. And you can always talk about the scale. The scale in our perspective will always be 1 inch equals 1 foot. So you have here your name and the plate number. Someone who's really famous for utilizing perspective in their artwork is MC Escher. So I'm just going to show you a few of his designs, but you can see, I'm sure it'll evoke your memories of his work, stairways going to nowhere and such. So that's MC Escher. You can look at his work further. So when we talk about perspective, there's some terms we need to understand. For example, we need to understand 1- and 2-point perspective. 1-point perspective is when the full square of the box faces you. So I'll use this little iPhone plug. So this is 1-point perspective, where the square of the box is facing you. 2-point perspective is where the corner of the box is facing you. So in 1 point, all these 4 corners recede to a center vanishing point. In 2-point, you have the corner of the box and it recedes to the right and to the left vanishing point, okay, if that's a cube. So you have this idea of the cone of vision. So anything that's out of your peripheral vision, you won't see in a perspective drawing. Anytime your drawing exceeds kind of your cone of vision on your paper, your shapes will become distorted. So it's really important to try to stay tight within that cone of vision, or you'll get distortion. So the idea of foreshortening, when an object is moving extremely forward in space or looks like it's vanishing away rapidly in space, that's the idea of foreshortening. It becomes, in a 2-dimensional drawing, a compression of the image so that it appears to be receding in space or coming forward in space. You'll have a ground line. The ground line is going to be the bottom of whatever picture plane you're drawing, so like the frame of your perspective drawing. The horizon line. The horizon line is much like you'd think of it, where the sky and land meet. That line is known as the horizon line, and that's where the vanishing point is placed. The vanishing point is the point at which all lines come together to create depth in a perspective drawing. You have your line of sight. Your line of sight is your eye moving to that horizon line. That line from my eye to the horizon line is representative of the line of sight. And in a 3D world, it's me looking through a window, let's say. But when I compress that onto the drawing, it becomes a line that moves down the paper, and that's known as the line of sight. And it represents an imaginary dotted line going from the center of your eye to that vanish point at the center of the horizon line. So here we have a drawing. This is the HL, and that's going to stand for horizon line. And then we're also going to have some measuring points. So I'll explain those in depth a little further, but that's how you can make a perfect square or a perfect cube in perspective, is by using measure points. I'm also going to talk about orthogonal lines. Orthogonal lines are parallel lines such as railroad tracks. If you think about railroad tracks, they are parallel in reality, and if you're walking along the railroad tracks, they never converge. But in a perspective drawing, they will appear to converge at the vanishing point. And so those parallel lines that converge at the vanishing point are known as orthogonal lines, and they create depth in a perspective drawing. So you have your picture plane. Your picture plane is essentially, if you were looking at a pane of glass and you were drawing on that glass what you see out the window, that's known as your picture plane, and your paper is going to represent your picture plane. That's where our drawing is going to take place. Anything in front of the picture plane will be the real world. Anything behind the picture plane will be the perspective drawing we're creating. You have a station point. The station point is always at the base of your drawing, and it represents you or the I. So you're the station point. You'll also have a vanishing point, and that's what we talked about as the center where everything comes together. So here's a nice illustration of the picture plane. So you can imagine the person, their line of sight. They're trying to draw this object. So it's as if your paper is a sheet of glass and you're able to draw that object right on the page. So that's a little explanation of the picture plane. You don't have to understand all of these things in order to have a successful perspective composition, but a lot of these will help. So here's your typical one-point perspective. You have your vanishing point, you have your boxes here, and each of these boxes vanish into space, creating orthogonal lines. All right, so that's a one-point perspective where you're seated here from above and your object is parallel with the picture plane. Okay, so that's 1 point. Here's some more examples of orthogonal lines. You have all these things vanishing. So you have telephone poles. The top and bottom of the telephone pole are represented as orthogonal lines. These paver stones, these tables moving back in space, anything that's parallel in reality. Okay, so then we have the main things we're going to set up in our perspective composition, and that's what I'll be drawing with you today. And you should have all these handouts in your packet. But what we have is our horizon line here. We have our vanishing point here, our line of sight, our station point, and right here we have something known as the distance point. And that's something that's a little trickier to understand, but what you're going to do is take from your vanishing point to your station point, whatever that distance is, if it's 10 inches, 8 inches, in my case today I'm drawing very small to be 5 inches, I will then go from the vanishing point 5 inches to the left, 5 inches to the right, and that will create my distance point. And when I connect the distance point and the station point, I will have a perfect 90-degree triangle. So this is the 45-degree triangle here. Here's the 90. But when I connect the distance point also on this side, I will complete this 90 here, okay? So let's begin by doing that. And that's our initial setup for a one-point perspective. So see if you can see where I'm drawing here. The sun is shining a little brighter now, so it's kind of hard to see. But what I have is I have established my horizon line across my paper. I have established my vanishing point in the center here. And then coming down from the center to the bottom here is my station point. This line is 5 inches. And because this line is 5 inches long, I'm going to go 5 inches to the right and 5 inches to the left, And I'm going to join these, this 5-inch mark to my station point mark, okay? So I'm going to try to position this a little more closely so you can perhaps see it. It's very bright in here today, so it's hard to read the actual drawing. Hopefully it'll pick it up a little better as I draw. So again, I'm going to connect my distance point to my station point. Okay, so these are going to be my DP, and I have a distance point right, and I'll have a distance point left. This is going to be my vanish point, and of course this is my horizon line, so I'm using all abbreviations. And then down here where you can't see because of my ledge, but right here, this represents U, and that's called the SP, or station point, okay? And so that's just terminology you need to learn when you're working with perspective, and luckily in your packet you have that list of definitions. And then you also have this sheet called How to Set Up a 1-Point Perspective, and it gives you a list and a diagram at the bottom. So in your packet, you can refer to that in order to set up this main grid. The main grid here that's really important, we begin with every time, okay? So you'll always begin by setting this up. And whatever size paper you have, if it's 18 by 24, then you're going to set it up at 9 inches or maybe 10 inches above the bottom of the page to create your horizon line. And then if your paper is 24 inches wide, then your vantage point will be at 12 inches into the page in the center, okay? And so I'll begin by reviewing 1-point perspective. So in 1-point perspective, we would draw maybe an inch. Because I'm drawing very small, you'd probably draw a 2-inch by 2-inch square. That's normally what I assign here and here. So this is just a small square. It's a perfect square. It's 1 by 1 inch square. And then from each of these 4 corners, okay, and if I label them, I'm going to vanish to the center vanish point. So I hope you can see this. And what I'd like to do is I'd always like to line up my ruler to the vanish point and then vanish from the vanish point to each of those 4 corners. And I am going to do that here. So now I have each of the 4 corners vanished to the central vanish point. And maybe when you were a kid, you did something like create a box and then make another box within it and then connect those 2 boxes together to make a cube. That's essentially what we're going to do. We're going to connect from the side of the box, and I can place this anywhere I'd like, to create the back of the box. And I'm just going to follow along. So I'm on the right side, top to bottom. Then from the bottom right, I'm going to go to the bottom left. From the bottom left, I'm going to go to the top right. Just trying to keep my ruler parallel. I could also use a T-square. That would be very helpful. And so there's my first 1-point cube, very simply. So that's 1-point perspective, where everything vanishes to the central point. 2-point perspective is if I do the same idea, but I take a 1-inch line, or in your case, if you're drawing on a bigger paper, a 2-inch line, and I'm going to draw the corner of the box now, not the entire square, because in 2-point perspective, I'm going to, Sorry about that. In 2-point perspective, I'm going to vanish from the top and the bottom of that line segment to each DPL and DPR. So in 1 point, I vanished everything to the central 1 vanish point. In 2 point, I'm going to vanish everything to 2 separate points. So top and bottom to the DP left, distance point left, top and bottom to the distance point right. So let's go ahead and do that now, so it'll be more clear. Okay, so again, top and bottom of this line segment to my vantage point on the right. You can even call it VP. Top and bottom of this line segment to the vantage point on the left. So that's the beginning of my 2-point box. Now I can place the sides of the box anywhere I'd like right now. So I'm just going to make a decision of where I'm going to place that, and that's going to be the side of my box. I need the left and the right side of my box, so I'll do that now. Here's the left and right side of my box. And then from the top and bottom of this new line segment I've created, I'm going to vanish to the only vanish point I haven't already vanished it to. So it's already vanishing here. So now I'm going to then vanish it here. Okay, so it's getting a little bit more lines, a little bit more challenging to manage. And then from the bottom and top here, I'm going to vanish as well. So I'm going to go there and there. So my 2-point box is starting to take shape. I just have one more line that is missing, and that's to connect this back corner here and here, and I hope you can visualize that. But what it is a line that then makes the back of the box. So here's the front of my 1-point cube and the back of the box there. And this is the front of my 2-point cube. So because the corner's facing me, I have a left front and a right front. And then you can see the transparent box that creates the background, okay? So then another important thing to understand when you're working with 1 and 2 point is how to make a perfect cube. And once you can make a perfect cube, everything else will fall into line, okay? Because once you know that you have a 1 by 1 by 1 or a 2 by 2 by 2 perfect cube, remember our scale, when we were talking about our signature, our scale is 1 inch is equal to 1 foot, okay? So once I know that this is a 1 by 1 foot cube or inch cube, I then know that this is 1 foot in depth. And when I can understand the depth, I can then start creating a real space with measurements. So that's why that's important. So let's practice making a cube in 1 and 2 point. So again, with a 1-point cube, and I'll do it down here so you can see it a little better. I'm going to create a square that is, in my case, 1 by 1 inch. In your case, it might be 2 by 2 inch if you have a little bigger paper than I do. I do prefer working bigger, but with the video, it's easier to see if I draw smaller. So here's my perfect cube. I can vanish those cubes again to that center. Each 4 of the 4 corners of the cubes I can vanish to the vanish point at the center of my paper. Okay, Now, when I want to make a perfect cube, I have to understand exactly where the back of the cube is. I can't just randomly predict it like I did up here. I actually have to physically know where the back of the cube is and know that it is at the center of the cube. And so for that, I'm going to use a method of finding the center of a square. If I have a square and I want to find the center of it, I just X the square, right? And that will give me the center, because where this corner to corner and this corner to corner meet, that tells me the center, okay? So if I can predict this X, I can then predict where that cube's center is, and it'll be a perfect cube. So what I'm going to do is I'm going to go from the bottom left part of my 1-point box to my DPR, and I'm going to make this a dotted line because this line is a measuring line. It's not a true line of my box. Okay. And then I'm going to go from the bottom right corner of my box, and I'm going to go to that left-hand DP where those intersect my box. That's what's going to give me this X shape. So here and here, if this is the center of the X, where that dotted line intersects my vanishing of my cube, I can place the back end of my box. If I place the back end there, I can then complete the box using that as my guide. And I have to come up through the box and over as straight as I can and connect through the back. So I'm doing the same movements, just now I know that this is the center of the X on my box, and that determines the back of my box. Okay, so I have a visitor, that's my cat Toulouse. So here's the perfect cube. So this is a cube. All right, this is just a box, nothing special about this box, but this is a cube. And so this I can use as a unit of measure in the future, in future assignments. Now, you can do the same thing in 2-point to find a perfect cube, because this right now is just a box, a rectangular box. It may look cube-like, but I have no way of knowing because I didn't measure to create it. But it gets a little more complicated when you want to make a 2-point, because in the 1-point cube, I'm vanishing to the vanishing points of 2-point. So I need to find an alternate point to use to measure when I have a 2-point box. And that's where your measure point comes in. The measure point is a little tricky, but basically if you physically measure from the station point to your distance point, for example, in my case, it's 7 inches. So I know it's 7 inches, then I take and lay 7 inches on my distance point and bring that across here, and that creates my measure point, and that's the right measure point. Okay? So let me review a little bit. This distance from vantage point to station point is 5 inches. And from vantage point here to the right is 5 inches. And vantage point here to the right, this is also 5 inches, okay? Now that setup must be correct in order to create a 90-degree triangle, which is the geometry of perspective. If any of those things are wrong, this won't work because it's all about the geometry. So if I measure physically this station point to the distance point, it should be equal on both sides, but I'm just going to double check. So I want it to be 7 inches yet again over here. So I'm going to measure, and it is 7 inches, okay? So then I'm going to take my 7 inches and make a mark here. So I go from 7 to 0, and I get a mark on my horizon line. That mark is going to be my new measure point left. And these measure points, and I'm going to bold them a bit, are how we are going to determine in a 2-point scenario where a cube is. So we'll use those as our measure points. We're going to have to employ another mechanism, which is called what I call a T. But if you have a 1-inch line here, and you create a T on the top or bottom, depending if you're above or below the horizon line, this T will help you to measure on a 2-point. Okay, so let's go ahead and do that now. I'm going to create another 1-inch line that's going to represent a corner of my box in 2-point. And because I'm below the horizon line, I'm going to make a T. So from that 1-inch line, I'm going to come 1 inch to the right and 1 inch to the left. You'll need to practice this many times to really understand it. I actually recommend practicing each scenario 9 times on separate pages. So start by doing just boxes, do 9 boxes. Then do 9 cubes. Then try your 2-point, do 9 2-point boxes, okay? Then do 9 2-point cubes. Okay, so that's the method of practice I recommend, but I want to just show you quickly how the whole perspective fits together between 1 and 2-point. So review, we've made a 1-inch line. We have then created a T at the bottom, which is 1 inch to the left, 1 inch to the right for a total of 2 inches. It's double our distance that we've created for our line. Then just like in 2-point, from the top and bottom of the segment, I'm going to vanish to the left and right hand vanish points. So I'm going to go from here and here. And then on this one, I'm going to go here. And you can see your paper gets a lot of lines in it from all this perspective work. You'll be using pencil. I'm just trying to use this marker so that you can see it really well when I'm doing the demonstration. And it's even a little hard to see at that. So in my previous 2-point, I just put my lines that represented the sides anywhere I want. But now, because it's a perfect cube, I have to place them exactly using this T and my measure point. And this is a little tricky, but if this is my left hand measure point of the T, I'm going to go to the opposite, the right hand measure point. And again, this is just a measuring line, so this will be a dotted line. I'm going to go to the right hand, and I'm going to, from the right hand corner of my T, I'm going to do a dotted line, and that's going to go to the left hand measure point over here. Now, this placement here, the first intersection of these dotted lines with a true line of my cube, a vanishing line of my cube, will be where I place the vertical line of my box. And that's how I know it will be a perfect cube. So from the top and bottom of each of these, I'm going to vanish to the opposite measure points. I know this is a lot of information, but until you practice it, it's really, so you may have to watch this video a few times. And I'm going to vanish top and bottom to my alternate distance points. And that's going to give me the back of my box. So here's the back of my box right here. And I'm going to line those up and draw a line. So here's the top of my box. Here's the front corner that I started with. Here's my T I created. And here's the sides of my box. So I will shade them in now. Okay. So now that's a 2-point cube. So that's the process for measuring. So in 1 point, to measure for a cube, you use your distance point left and distance point right to create an X in your cube and find that center, okay? So this is making a 1-point cube right here. All right. In 2-point, to create a cube, you need to make a T. So make a T. Now, the T is based off of whatever your line segment is. You're starting with the corner of your cube. So if you're above the horizon line, you make your T above. So if this is 1 inch, your T will be a total of 2 inches. It'll be 1 inch to the left and 1 inch to the right for a total of 2 inches, okay? If it's below, it'll be below. So in a 2-point cube, you want to make a T, and then you're going to vanish your line segment to your vanishing points on the right and the left, and then you're going to use your T with a dotted line to go to your measure point. All right? So that's the difference between 1 and 2-point, and how to make a 1-point cube and a 2-point cube. Give it a try on your own. I understand that the 2-point cube will be very challenging. So if you don't get that far, that's okay. We'll do more assignments to explore that. All right, I hope you enjoyed perspective. Bye.